Okay, before we start, I want to make sure that you know that this video will not make it so effects are visible to other players. This is only effects that show to the player casting the ability. And on the next video, I will make sure to explain how to make it so everyone sees the effect. Okay. Okay, now we can continue. Okay, hello. So you clicked on this video for one specific thing, so let's get straight into the point. I made this video just so I don't hear stupid questions such as, do I need vector 3 for this? Or do I need for loops for this? Do I need math huge for this? Stuff like that, you know, things that don't actually make sense. And this video won't help anyone that is like experienced enough in front-end VFX. Well, front-end scripting, sorry, for VFX. This will only help those who are new to it and have a small clue about it. And hence, if you are experienced enough, then you can check if I said anything wrong here and just correct me later. But this shouldn't help you if you are experienced enough. Okay, let's get straight into the point. I know a lot of people here don't know the difference between a script, a normal script, and the other three types. You have a local script, which is this thing right in the workspace. You have a script, is this other one, and you have a module script. The scripts by themselves are server-sided script. Anything the server has access to, it will run on it. Basically, if I just print hello world inside of this and just put it, I don't know, in lighting, it will run normally. If I put it in players, probably will run. I don't know, I've never tried that. If I come to a local script, this is a script that it will run in scenarios where it only belongs to one player, or that a player has access to it. Basically, if I put it in workspace, it won't run because every single player has access to it. And it won't be like local, it will be like global. So if I want this to run, I will need it to put it in star pack, star player script, or star UI, or replicated first works then. And then you have module scripts, which basically are just scripts that return values. For example, in this case, it makes a variable called module. Module could be either a number like 66. It could be a string, for example, hello world, like this. It could be a boolean, meaning it could be true only. But by default, it's a table. So it's just like this. We will be using modules later in the video today, so just know that you will need them. Okay. I know for a fact that most of you don't even know what a script is, so let me explain how variables at least work. Variables, you basically assign like a name to a value. You see how variable name you can do underscores, but you can't do spaces. This will be an error. Now if I do like 15s, this won't work either. You can't start the variable name with letters, but you can't use special characters. You see, any doesn't let me. Okay, variable, of course, saves data types. I know majority of you guys know this. There's a number. This is a string of text. You have tables, which basically save multiple values in them. For example, 15 and string. Then you also have booleans, which basically are true or false. You can also save parts, for example, workspace. This means we're accessing the workspace, and then base plate. This means we're getting into workspace and then accessing base plate, which is inside of workspace. And you can also save vector 3s, which are basically axes. It's basically like a position, or yeah, it's a vector. It has axis, which is x. For example, you can put any number inside of here, -5, 12, 12.5. Y, the same thing, and Z, the same thing. If you want a vector value 0, you can do this, or you can even do this. Vector 3.0 is the same as doing this, and vector 3.1 is the same as doing this. Okay, this is a few recommendations. Let's get into functions, which are defined the same way. Local function and then function name. A function can get parameters passed into it. For example, like this. And let's say we want the function to do something, then we have to call the number, call the function, sorry, and this will do something. For example, if we pass in print hello world, whenever we call this, we will call this function. We'll basically execute everything inside of this function. Since we have parameter 1 and parameter 2, let's make use of them and then do 10 plus, 10 and then 5. And in here, we're going to do print parameter 1 plus parameter 2. This basically print 10 plus 5, which equals 15. If you don't know what a print does, it is basically, it makes a new line inside of the output right here, which you can toggle in the view tab. Sorry, this is in Spanish, sorry, but it's the view tab, and then it's one of these three. I don't know which one, it's probably this one. No, it's the first one, sorry. Functions can also return values. So instead of just printing them, we want to return them. So just do something like this, and we can save this in a variable too. And what returning values does is basically it stops any code after this from running, but it gives you a value. If you don't save that value anywhere, that value goes to the void, basically. But if you do, you can save it in a variable, and you have parameter 1 plus parameter 2, and we can call this function add, and then this add, and this makes a function that adds 2 numbers, basically. Okay, now we're gonna get into loops. Loops basically just they repeat code and functions throughout specific iterations or conditions while they're met. Basically, if I want to repeat a specific line of code, like a specific amount of times, I'm gonna use a loop. I shouldn't just copy paste the same line of code. You probably would if you were stupid, but you were. I know you're not, and I know you're watching this to become more intelligent than stupid. So let's do this easily. Let's make a for. We're gonna need for a variable. This is whatever name we want. By default, people just use I for iterations or index, whatever they mean. We're gonna need a start number and then end number. And there's also a third variable called step, which I'll explain later. Okay, by default, we set a start number, for example, 5. We want an end number, which will be 10, you see. Now this will repeat the code 5 times. Basically, it will go for I starting at 5, getting to 10, do this. And then we have the step value, which means every time this code executes, I gets added step amount to it. Basically, step by default is 1. So whenever this code right here ends, for example, let's say it's print I gets added 1, and then I is 6, and then so every time this runs, it checks if I is more than 10, then it will stop the code and then continue running the thing after this. So whenever you do code right here, this will stop the code until this finishes, and then it will run everything after that. Now we have something similar with a while. While, for example, 1 equals 1, do this. And this means while this condition is true, which will always be true, do this. But since this will always be true, we're gonna need something to like stop the loop, because then it's going to like infinitely continue, and then it's going to use a lot of memory. And since this doesn't even have a pause between them, it's going to be draining all of your computer resources, and then the code will automatically stop or either crash your studio to prevent it from doing that. So we're gonna need to add like a new thing called task, and this task library is made for like threads and yielding, which is stopping the code. So we're gonna add task that wait. if no number is given to task.wait, which basically just waits a specific amount of time, then it will wait as minimum as possible, or to be precise, just one frame. One frame, since we are on a local script, will be whatever your frame rate is right now. For example, if mine is 144 FPS, it will wait one over 144, which is something like 0.00 something. Now, let's say that this condition stops being true, right? Let's do okay, let's make a variable called variable name and set it to 0, right? While variable name is less than 10, this is basic math, do this. And here we just add 1 to the value of variable name. So this we have done now is repeat this 10 times with a delay of 1 frame between each time, meaning it will take 10 frames to finish this. And once this finishes, then we print loop ended. If we run this right now, we're gonna just do nothing basically, because this is just a print. And then we have the last type of a loop, which is a repeat until, and then a condition. For example, let's say a random number is 0 until random number is 3, let's say. And we wanna get a random number. How do we get random numbers? So this is super easy. Random number is random, and we have it's the minimum number. For example, -1 to 4. This only gets entire numbers. Like, it doesn't get the decimal point. So if you do this, it won't work. Well, it will work, but it will start from, like, I think -2 or -1 or something like that. And we're gonna need to add a task wait, because we don't know how long this will take, and it will have the same problem as the while loop that executes infinitely. Okay, this is like the basics of scripts. With this you can do a lot of things, but there's more to Roblox. And let's continue with events. So we're gonna need user input service, which is a service that you get by doing game, then calling get service. And this service basically is used to handle inputs. What is a service? I won't explain it because I don't fucking know how to explain it. But to make it simple, a service helps us do functions around specific stuff in the game. If we type input service at input began, we get the event. This is like one of the most important things here. An event basically happens once in the entire it doesn't happen once, sorry. It happens multiple times, or can be executed at least once in the game, and you can either listen to it and connect a function again like this, or you can wait like this until it happens. But the good thing about events is not only that you can connect stuff to whatever happens, but that you can also get specific details of whatever happened. For example, a value, sorry, it's input and game process. So this will wait until an input is began, meaning that you held down a key, and this will return you some values. You see how we do this like this? Basically just think of this event right here, this input began, giving you 2 values that you have to save in a variable like this, or that you can connect to a function like this, input and game process. Of course, these names do not matter, by the way. And to clear your mind, you can also do it like this. Like a function handle input began, and it will be like input and game process, and you can connect a pre-made function to it. If this is simple, we can get on. Now that we know what this does, this will listen to an input. And since we've been messing around with if statements and stuff, oh wait, I forgot to show if statements. True. An if statement, well, it's super easy. Sorry, let's make another variable. Look up variable 2 is 5. If variable 2 equals 5, then print this variable equals 5. Else if variable 2 equals 6, then print this variable equals 6. Else, I don't know what to print. Okay, this is a simple explanation of if statements. Basically, we have a variable, right? We compare this variable to a different one. This double equal sign means comparing. If this is true, this right here, then this code inside of this thing will execute. Else, if it's not true, if this first thing is not true, then check. If it's 6, actually, then execute this one. Else, if it's neither of these, then execute this thing. In these 3 scenarios, we're printing only, so it's super easy. You can also have something like this. This is also valid. And please make sure to check whether your ends are in the correct position, because you can have an if inside of an if, like this. This is completely pointless, but this is true. And you see how there's an end, like it completely indented, and like differently indented, sorry. Okay, now let's get into our main thing. Now, the user input service input began event sends us 2 values, input and game processed, okay? Game processed means that the player is currently interacting with a chat or with like any UI, and so the input was used in that UI or chat or whatever. So if game processed, then we want to return. We want to end the function right here. We want to end everything running, because we don't want to execute anything if we are running if we are just chatting. And now we're gonna check. This input is an input object. It's not the same as the key. It's not the same as the mouse. It's not the same as any button or anything. Input just holds the values of the input. So input has key code, input has other input type, and more other stuff that you don't need to know to make this stuff. Now the key code is super easy. It means what key you press, and the user input type is either you press a keyboard or you press any of the 3 mouse buttons. In this case, we only want to need the key code, so we're gonna use an if statement again, and we're gonna do if input dot key code dot means this thing right here belongs to input. If the key code from input equals enum key code e, in this case I'm using the key code e. Enum is a list of categorized values under a specific name. In this case, we have a list of key codes, and then from that list we get e. So key code belongs to enum, and e belongs to key code. And this right here is an enum too. So we're comparing these two. Then we want to do something, and let's say we want to do a hello world. Now, if we run this code, super simple. We're gonna get to the cool stuff soon. Don't worry. And we press E. You're gonna see how whenever I press E, it prints hello world. Now remember what I explained at the start of this video about module scripts? Let's get to work on this. Okay, let's make a new module script. And remember what I told you, that a module script can return any type of data type, like a 5, a string, or stuff like that. Then let's only return a function, okay? Since we only want to play an effect, right? So let's just call this module script play ball effect, and we're gonna give this function a character. Okay, this is the only parameter that we want, or that we need for now. So now how do we access this function right here from this local script right here? Well, it's super simple. We're just gonna have to save it in a variable, and we're gonna have to assign it a name. For example, effect. We're just gonna do require, meaning that we're gonna target any module script. And since it's inside of our local script, we're gonna do script wait for child, meaning it's going to wait for any object inside of this, which is called a child usually, with the name play ball effect. You see? And now we have accessed this script, and this script returns only a function. So essentially, effect would be the same as doing a local function effect and character, just like this. These two would be essentially the same, but since I want you guys to learn how to use modules to like style stuff in modules or use them in modules so that you can call them from any code, I'd rather you guys practice using modules. They are super simple and you can do a lot of stuff with them. Okay, now we're gonna need effect. We're gonna get effect, sorry. And now we also need a character. How the fuck do we get the character? This is super simple. Again, you remember how we got user input service? Let's now get the players service. This controls all of the players in the world. Right now there's only one player in this server, which is Juaniitrox, which is me. You see, this is all of the player scripts and stuff, etc. Okay, from players, we're now gonna want the player that is executing this code. How do we know that? It's super simple. It's called the local player. If you want, it's basically the player that the local script is running for. Okay. Remember that I told you that a local script can only run when a singular client access is given to it. Basically, that it is defined who can access this code. Well, this case, this is you. This is basically the player executing this code. And since effect is a function, the same way we can call functions to do stuff, we're going to call effect inside of our if, and going to pass local player dot character. And now we're basically done with our local script. This plays the effect that we gave this whenever we press the key code E. Right. Now let's get into work with this playable effect. For now, let me show you that if I do hello world like this, and I come and I just press play, and then I press E, it executes too. It's basically acting like its own function. Okay, so we want to play an effect now. I'm assuming you are familiarized with effect plugins and stuff that works with it. So if you have any VFX suite like this, like I have the VFX util, it just emits stuff. I made this simple fire thing that I can enable to it, like this. And I'm gonna put this effect part inside of my play ball effect, okay? This is now a child of the module. And these things inside of this part are the children of my part, of my effect. Now, let's say we want to make the effect appear in front of us and then play the explosion that I just played. Okay, first of all, we're gonna have to make a clone of our part so that we can make multiple of them. Because if we just get the original part, then we won't have anything to reference later. So let's make a cloned effect, and we're just gonna do script.effect part. Why script.effect part and not why script.wait for child? Because this part is usually already loaded by the time the module loaded, because this won't instantly execute, but this will. So we don't need to wait on a thing that has to instantly execute. It doesn't have to instantly execute, sorry. And so then we're gonna call clone on this, okay? Now, the way that Roblox works, whenever you refer to an object, you can type any property that belongs to the object. In this case, we're gonna can change any of these. And to make sure that this works, I'm gonna put C-frame, which is a coordinate frame. A C-frame basically holds a position, and an orientation. And both of them are also vector 3s. Remember when I explained them that they have 3 axes? If I come here into the workspace and I check this right here, you see C-frame. It has position. This is the position C-frame, and this is the orientation XYZ, XYZ. You see? Super simple. C-frame actually is a lot more detailed than this, but I won't go more in detail on how it works because it's going to fry your brain. And I know you frauds do not have enough brain capacity to even understand C-frame. So I'm just make it simple for you. Now, we can't just set this C-frame to a part. That's just not how it works. So instead, we're gonna get the pivot of our character. Since characters in Roblox are models, like this model, you see, every model has the method or function the same way we have connect for events. This has, or clone for parts like this has get pivot, and this just returns a C-frame. This gives us a C-frame that basically refers to the primary part of the model or the pivot position, basically where the character is. It's a reference for the position of the character. This won't always work because sometimes this pivot can be offset. But for now, for R15, for what I'm showcasing here, this will work. If you want an alternative version, we can do humanoid root part dot C-frame. Okay, this is the core part. This is basically like the straight part that always works as a reference. It will be like parallel. It will be like perpendicular to the floor always. Or whenever it's like standing, it will be like straight. It's like a good reference. This is like the center of the character. This is the humanoid root part, which is the center, and we get the C-frame of the humanoid root part. So now this cloned effect will appear inside of us. That sounds weird. And now let's say we want this to appear in front of us. We're gonna have to offset it. And how do we offset it? We'll make a new C-frame like this, the same way we make a new vector. And we're gonna give it also 3 axes. We're gonna give it a 0, another 0, because X refers to left and right movements, so we want 0 of that. Y refers to up and down movements, we want 0 of that. And Z refers to front and back. But instead of being positive for front, it's positive for back. So we're gonna need like a negative number to put it in front of us. And just like this, we made an effect that appears in front of us. And now we're gonna set the parent, which is it's the parent. It's like where it's in. Basically, this module parent is local script, as you see here, because it's inside of local script, and this local script parent is starter player script because it's inside of this. We also want to play the explosion effect. So for loops iterate through a specific amount of things. Well, for loops also iterate through tables, the index and the value exactly. So let's say we have table example. We have string true and false, right? Whatever we do for I, the same way we did before, and now we add a second variable, b, which usually refers to value, in, y in, because it's inside of table, do. Now, let me explain this with a different word. For key, value, table example, this doesn't have any name for the variables inside of it. This is an array. And an array has numeric indexes. So now if I did table example 1 like this, in between brackets, this will refer to string. If I did 2, this will refer to true. If I did 3, to true. And if I did 4, to false. Now, key is the number. It's basically that number. And when going through everything inside of a table, we don't always need a number. Sometimes we just need the values. So in this case, I'm gonna just get rid of that. And we will get rid of table example 2. And now we're going to do a cool method, which is called clone effect, and we colon again and get descendants. Get descendants basically gets everything inside of the part, but it's also gets everything inside of the parts inside of that part. Basically, if I did get children, which is it's a similar method, children will only give me explosion, fire, and smoke, because these three are children. But the children of explosion, circular, spark, spike waves, and spikes, these four are children of explosion and descendants of effect part, because they're not part of effect part, but they are inside of it. So get descendants gets even this inside of here. Now we don't want to call this value anymore because we want to refer to the particles. So let's just call it particle. Now, if we go through everything here, just treat them all like particles, we're gonna get an error. Why? Because explosion is not a particle. So we're gonna do if particle is a particle emitter, then we're gonna run this code. Particle emitter, the same way we have clone and get descendants and is a, the same way we have that, we have emit, which is a method of particle emitters. And if we just put one here, it will emit one particle for each of all of our particles inside our effect part. Okay. Now, if instead of doing that, we get an attribute again, which by default comes with pretty much every single emit plugin, which is called emit count, and we get it right here by referring to it as a string emit count like this. We will get emit count and we will get its value, which is in this case for a circle aura just 2. So particle emitter will emit 2 in case it's circle aura. It will emit 1 if it's spark. It will emit 4 if it's spike wave. It will emit 12 if it spikes. Do we get that? So now, if I come here and I press E, you see how it spawns and instantly plays an effect. Okay, but this is so lame. Remember the task.wait that we used earlier, like this? If we add a number to this and let's say 1, then we can destroy the effect afterwards, and we have saved in memory, because a lot of parts in our world is not good to have. So we can just make a lot of them, and you see how after a second they disappear. But this isn't too practical because this stops all of the code and then resume. So let's say we want to delete it. To make a separate thread, we can call task.spawn and spawn a function, and then we can delete it right here. But since task.spawn runs instantly, we want to add a time, and we would like logically do task.wait 1, but this is wrong, because why would do this when there's a function called task.delay which does exactly that? And this right here is how you delete a part after 1 second. This is like a super simple function. There's a lot of better ways to do this, but this is essentially the best. Do not trust anyone that tells you to use this. This is wrong idea to use. Do not use debris. Even though it looks fine, it is not fine. It's deprecated basically. Well, it's not deprecated, but it shouldn't be used. Okay, but this thing, it's still mid. I don't want this. So let's animate it, right? Let's call TweenService, another service. This TweenService lets us make an animation of properties of a part changing. Meaning that if we want to animate the clone effect dot size like this, and maybe let's say we make the size 555 like this, but we don't want this to be instant, we can just make an animation using TweenService. Now, the way TweenService works is basically you will give it a part, you will give it settings on how to animate that part, and then you will give it goals, basically the properties that you want to change. To make it simple, let's make our settings, or actually it's called info because it's a tween, it's a tween info like this. And the tween info accepts a time, let's say in this case it's 0.5, an easing style, which is an enum, again, it's a list with it, which is categorized into an easing style. Let's say easing style linear, we don't want anything. Since it's linear, this one is pointless. But easing direction, if you know what easings are because you're an animator or anything, then you can do this right here. Repeat count, in this case I don't want it to repeat, so let's give it 0 versus false, and delay time, let's give it 0. Now, majority of these are pointless. Why? By default, the easing direction is out. By default, the repeat count is 0. By default, the reverses is set to false. And by default, the delay time is 0. So if we just delete this, we get this. But by default, the easing style is not linear. So I'm gonna just keep that right here, right there. Now this is like the settings. So we want this, we're gonna want TweenService to animate the part moving forward, which is what I'll do, in 0.5 seconds with a linear easing style, meaning it will move like robotically, because it will move perfectly forward in 0.5 seconds. Now we're gonna add goals, which is a table. Why is it a table? Because that's how Roblox wants it to be. And we're gonna give goals a C frame, because this isn't just a table, it's a dictionary. We wanna make this C frame be the clone effect C frame again, since it's the current position and orientation. And we're gonna offset it by, let's say, 10 studs. Oh, something I forgot to say. C frame is, if we multiply a C frame by another C frame, we're multiplying it relatively to the C frame. Basically, if I multiply this by -5 here, this means it's moving -5 in the direction in which I'm looking at. If I was looking at a different direction, it will move 5 studs in front of me in that direction. This thing right here means it's moving 10 studs to the front. Why? Because this is our goal. This is our new C-frame. This is what we want this part to animate changing into. And now we're going to make a tween, which is an object too. But this is made by doing TweenService and calling a method called create. Okay, create will make a new tween. And to make this tween, we're going to need an instance, which is any object, any physical object in Roblox, which is in this case our clone effect. We're going to give it a tween info, which we just made here, which is our info, and we're going to give it goals, which is property table right here. And this just made us an animation. But this animation doesn't instantly play, so we're going to have to play it too. You see? But let's say you want this tween to, you want this thing to like emit right after the tween happens instead of emitting instantly. Okay, let's copy our thing. Let's do tween. And now we're going to do tween.completed and wait. We're going to wait until this event happens. And this event only happens when the tween is completed. So we're going to then put our code in here. And this is going to make a simple explosion that we just made. Okay. Now, let's try it out and see how it works. Now if I press E, you see how it moves forward for a few seconds and then explodes. This is super simple, and you can actually customize it now and just use a different style, for example, cubic, and give it like a, instead of 10, let's move it 15 forward. And you're gonna see now that instead of moving 10 studs to the front, it moves 15, and it's super fast because it's a easing style. And then after a second it deletes, and this is like a super simple thing. Now, let's say instead of moving forward, we want our part to orbit around us. Okay, we can do this super easily. We're gonna delete our twin. We don't need a twin anymore for this. So we can delete this. And I'm gonna leave this down here. Okay. So let's go through what we have right now. Okay, we have a clone effect, and we set the C-frame of that clone effect to the C-frame of our root part, which is the center of our character, and we move it 5 studs to the front. Now, let's say we want our part to orbit around us. Okay. To do this, we're gonna need to use trigonometry. A lot of people hate this, but it's super easy to understand. Okay, let's make a loop then, a for loop again. Let's start on angle. Let's call our variable angle, since we now do need the number. And let's start at 0 and then at 360 degrees, because it's a full circle, you know. And let's make this step 2, so it's fast. Now we're gonna add a task.wait, because we do want to see each change. Because if we don't add a task.wait, this is not going to happen all after a few frames. This is going to happen all in one frame. Sorry. And hence we won't even see the part spinning. It will just instantly hop onto this thing right here, because it ended and then it played this. Now, since Roblox does not use degrees for math dot sine and math cosine, we're gonna have to convert this angle into radians. So we're gonna do math rad. This method right here of math converts whatever number you give it into a radian. This is essentially a function of the library math. It's the same thing as doing task wait, but instead of here we're doing math, the rad, and this specific function. This doesn't stop the code. Okay, and since we're gonna use trigonometry and we wanna make an orbit around as a circle, we're gonna need a sine of this angle that we just got. So we're gonna need math sine. I'm gonna also need the cosine, because we need both of them to make a circle. Since they both make a wave, then that complements itself in order to move x and y in a 2D table. But in 3D, we're gonna use x and z since it's front and back. And now we're gonna do clone effect dot cframe again, but instead of multiplying like this, like we're doing here, we're gonna do sine, 0, and cosine. This means that at 0, our part should be at 1 stud behind us. Okay, so if we try this out now, we're gonna see that it makes a fast spin around our player. Oh, well, a short spin, actually. And then explodes, you see? It starts from behind us and does it like this. If you want to make the effect work the other way, you can instead make it start at 360 and at 0 and put it to go down by -2. And now we have a code that runs the other way. So you want it to start in front of you. Let's use negative cosine, since it's the z-axis. And now it starts in front of you and then goes back and then goes back to the front of you. But this is too short. This is like a small circle. So let's make a bigger radius. Let's call our radius variable. Let's give our radius variable a value of 6, and then multiply our sine and cosine by that radius. This is probably going to be super hard for some of you, because some of you, I know, you gave up on math super easily. But this is actually super simple. Like, this is just getting the value of this angle at a specific moment and getting the x and z of that moment, basically. And radius, this is just like the size of the ball. And so now by multiplying that radius by 6, by default it's 1. So 1 times 6 is 6. Now we have a part that has an orbit of 6 studs around us. And it just moves like that. You see? And then once it finishes, it explodes. Just like that. Oh, since it's relative to us, if you rotate or move like that, actually you see how it's relative to our player, so it will move with us. Let's say we want the aura that this has right here like this. Let's say we want to enable this aura, but we don't want to enable the entirety of the part. Let's make this simple as it gets. Let's put the part back in here, and then let's do a loop right here that instead of getting all the descendants gets all the children of our part. And if it's a particle emitter, then particle enable, then true. We're setting the enabled property, meaning that it's running of all the particles that are children of a part. So it's just fire and smoke, and not the ones inside of the attachment. To be enabled, set to true. And now we have a part with a fire aura rotating around us. But let's say we want to disable this fire aura before, sorry, not before, after we end. Then we're gonna get clone effect, get descendants, and since we wanna get all of the particles in here, we're gonna do particle and then enabled and then set to false. And it's the same logic as here, but since the explosion particles are already set to enabled false, this won't matter much. And this will make this to go back to enable.false. You see? Enable set to false, sorry, not dot false. Okay, this should be self-explanatory. Now let's see it in action again. You're gonna see now I press E and it's on fire now. And then it explodes like this. If you want to make this faster, double the step from -2 to -4. And I just press E and you see how it goes faster now. And let's say we want to make this ball fade away. Let's do it super easily. Let's make a new tween with what we know, like this. Let's make it in a second. And let's make the goal, the transparency 1, and size be vector 3, the new 333. So our part is 2 to 2, it will be 1 bigger in size. And now let's make a tween. And like this, we need TweenService. We make a tween with our clone effect. Since the clone effect itself is the ball, it's not the particles inside of it. We'll give it an info, a settings for the animation, and then we'll give it goals for what we want to do on the animations. And then we play the tween. And since we don't want to wait on this tween, we can just keep it like this and make it so after 1 second it deletes no matter what, no matter if the tween has completed or not. I'm at any place. Okay, so now if I press E, it finishes and then and then the ball fades away. You see? This is super simple. And with this same logic, you can actually make quite a few parts appear around you. Let's make a clone of our module script. Let's say ring of balls. I won't delete it. I'm gonna delete this though, and I'll move all of this inside of this for loop. And now let's say we want to do 5 balls around us. Okay, let's say amount of balls is 5. Okay, so let's do I is it's 1 to 5. Okay, Now, how do we get angle? We do angle equals 360, which is a full circle divided by the amount of balls that we want, times I. 5, well, I don't know what number it gives us, but it gives us a small number, and if we multiply by I, for example, by 2, we get the second step and get every single step of our division, and hence we get a full circle. Now we want to place this on sine, 0 cosine, and we made a new ball effect on each angle that we got from the amount of balls. And so now we want to wanna emit all of the particles by doing the same thing as before, and we're gonna delete them too. Like this. And now I'll come to the local script, by the way, and change this for ring of balls, because we don't want the play ball effect, we want the ring of balls now. I'm gonna play the game and I press E, sorry. And you see how there's a small 1 frame delay between each one of these. We have a ring of 5 points, which is essentially a pentagon. That plays, wait, I forgot, sorry, it's get descendants here. That emits all of the particles inside of it. Now we're gonna remove the task.wait since we don't need it anymore, since we want all of the bolts to appear at the same time. And if I press E, you see how all of them appear at the same time. Okay. Now we have 5 balls that appear around of us. And if we wanted to make these balls rotate around us, we can simply spawn a new thread. And now we can do simple things such as, let's set start angle. Let's make a new variable called end angle, okay? End angle would be the angle, like we're gonna make each ball do a full spin around us and then go back to its original position, okay? And then make the balls fade away after that. So the end angle would be the angle plus 100 plus 360, okay? And now we're gonna do, well, angle is less than end angle, and we're essentially gonna copy this, but instead of using the same angle, we're just gonna do, I'm gonna show you what delta time is. Let's say you have to update something every single frame, right? But if you have different frame rates and if you use a specific number every frame rate, you're gonna have a problem where the guy with more frames will have a faster updating thing, and the one with less frames will not have as fast of movement. So to do this, we have to use delta time, which means if we save the time that task.wait gives us, like this, we get the delta. Delta basically is the time between frames, or well, the time between execution times. So here we stop the code for a frame like this, and so let's say this is at time 0. We start a stopwatch here. This is 0, and this right here is 0.016, which is 1 frame in case you had 60 FPS. So now to make this constantly update for all of our frame rates, we're gonna add to angle, we're gonna add delta, because it's the time between each frame, times the speed at which we want. So let's say delta equals to 1 second. Okay, so in 1 second, how much should the ball move? Let's say it has to move 180 degrees in 1 second. Then each frame time multiplied by 180 will give the code the specific movement that it has to do in that frame, okay? And now angle changes every single frame. And we don't need to add another task wait down here because we already do it here. This already stops the code, but we save it in a variable. Okay, and now we're gonna do the same thing as we did here, but do it here. And now if I press play, I'm sorry if this is confusing. I tried my best. See how they rotate after that. But since it takes 1 second to delete, no matter what, since we put this here, let's remove it here and let's do a task.wait. Since we are already inside of a task.spawn, let's do 1 second after the loop finishes. Okay. Let's say let's tween out our balls. Okay. Let's give this a tween info new 0.5 and let's make it linear and let's make it transparency is 1 so that they fade away. And now let's make a tween like this. And let's make a cloud effect since we want that. Info so that it takes 0.5 seconds and it's a linearizing style. And let's give it our goal, which is just to get to transparency equals 1. And then let's play our tween. And no matter what, after 1 second, it will destroy this. And now, if we do the same thing, if we come into our game and press E, after 1 second, you see that they fade away. And that's the easiest thing I can do for you. Like that's the best explanation on how to do orbits, how to do effects that orbit around the player, how to tween stuff, how to play cool effects. I'll give you a more detailed explanation on the next video that I make about this. I'm sorry if you did not understand this last part. I'll leave the code right here for you to check it now. But basically what I'm doing here is I'm making a while loop that will execute every single frame possible, or like a resumption cycle that it can, while this angle is less than the end angle. Okay. And this right here, this is probably the most confusing thing because I know nobody gets delta time somehow. But this is just making sure that 180 degrees is consistent between each frame. Okay. So if a frame takes 0.5 seconds, so you are at 2 FPS basically, then in one frame you move 90 degrees, and then the next one you move another 90 degrees. Okay. This is the same thing that I explained. Radians basically is the radian conversion. It's the same. It's just a different unit for measuring angles. Okay. Meaning a degree is just like 1 degree, you know. But then a radian, in radians, 180 degrees equals math pi in radians. Basically, p radians is 180 degrees. And then we just make it move by updating the angle every frame. Okay, I hope this whole tutorial helped you at least understand. I know I'm not the best at explaining, and I hope you at least give me a chance. I will try to respond to comments that have genuine questions and aren't just trolls. So if you want to like this video or recommend it to someone or just tell me how I could improve it, just tell me and I'll listen to you guys. See you.